Hello.
Hello.
Hello, how are you?
Good, bro. Thank you.
Yeah, of course. That's good. So I saw that you wanted to go over mesostructure, ZE stereo isomers, cis trans RS, and priority of nomenclature,
Yeah,
right?
exactly.
Yeah. So let's do that. Okay. So let's first talk about RS configuration for chiral centers. So do you know what a chiral center is?
Yes, it's.
Uh-huh.
I think it's when a carbon is asymmetry.
Mhm. Yep, the carbon is asymmetric, meaning that it is going to be attached to four different groups, right? So four unique groups. So an example would be something like this, where this carbon here is a chiral center because there are four unique groups attached to it.
Yes.
There is an alcohol, a hydrogen, a methyl, and an ethyl group, like that, right? Now, when we assign R and S, we have to assign each group in priority of atomic number. So we see oxygen here has the highest atomic number, so that would be number one. Hydrogen would be number four, the least prioritized group because it has the
Yes.
lowest atomic number. Now, there is a tie between these two carbons right here. And when there's a tie, you look at the next atom, right? And then, or like you see what is it attached to, besides the chiral center. So if you look at this carbon right here, notice how that carbon is attached to three hydrogens, one, two, three. So you could draw that out right here, three hydrogens, whereas this carbon here is attached to one carbon and
Two,
two
two
hydrogens.
hydrogens.
Right. Uh-huh. And when you think of it like that, the carbon has a higher priority than the hydrogen does. So that's why this carbon here would take priority number two. This would take priority number three, like that, right?
Yeah.
And then when we go rotate it like in this
Likewise.
direction, clockwise, one, two, three, that is going to be R, right? And it will stay R because the important rule here is that the lowest priority group here has to be on the dash on the backside. If it is, then it'll stay as an R, right?
Yeah.
Now, if we flipped it, like let's say we had this instead, and we had this cover center where this is going to be the lowest priority group, and we do the same thing, one, two, three. It is still going clockwise, but it will not be R because the lowest priority group here, four, is on the front, the wedge, right? And so we would have to invert it to an S like that. So the technique there is just to do whatever it looks like and then invert it to the opposite if the lowest priority group is on a wedge like that, right?
Yeah.
Now,
Excuse me.
yep, yep.
How can we determine this when we have a chair structure?
Oh, a chair structure? Yeah. So if we have a chair structure like this, um, and let's say we have something like this, and then something like this, like that, right? Okay. And we can convert this into, let's see, one, two, the actual ring form like that, where if we number it like this, one, two, three, four, five, six, we can translate that to this flat cyclohexane. One, two, three, four, five, six. It does not matter how you number it or how you rotate it. What matters the most is you stay consistent with the number. For example, because I numbered it this way, at number one, we see an alcohol going up, right? And let's say up here is going to be wedge, and then down is going to be dash, right? So because the alcohol is going up on one, I'm gonna draw a wedged alcohol on carbon one like that. And we see on carbon four, we also see a bromine going up equatorially.
Equatorial.
So that's going to be a wedge as well, like that. Now, there are no color centers here because this carbon here, right, has an alcohol, a hydrogen, but these two R groups here are the exact same. They're not unique. So there is
Yeah.
like symmetry there, right? So let's add some more groups to make a color center here. Um, let's add, let's see, let's add, let's see, this group, and then let's put chlorine right there. Now we see at carbon three, this chlorine is going to go down, meaning that it's going to be a dash. So on carbon three at the flat structure, we have a chlorine right there. Now we have two Kara centers, right? Oh, three Kara centers actually. One here, and one here. Now,
Yes.
can you assign RS for this Kara center, let's say, for example?
The OH, the alcohol is 1, the
Yep.
hydrogen is 4,
Correct.
carbon number 2, it's
Uh-huh.
2,
Yep.
because there is the chlorine with the
Yep.
high atomic number,
Mm-hmm. Nice.
and the 6 is the third one.
Yes, correct. Nice. And we rotate one, two, three clockwise, which is going to be R, and it will stay as R because we see the lowest priority group hydrogen is on four, like that. Nice. So that's good. Let's have you try out this one here now.
Yes,
Hmm.
the chlor is 1,
Correct.
most priority.
Hmm.
There is a nitrogen that is outside the plane. It's going up, yeah.
This one here, this carbon here, number two.
No, I mean
Mhm.
the carbon number 3 make 4.
Mm. Oh, carbon number three is the chiral center that we're trying to assign RS. So we won't look at this carbon here. We're looking at the atoms directly attached to this carbon, which is the chlorine, this carbon 2, this carbon 4, and this invisible implied hydrogen here.
Hydrogen, yes.
Right. So let's draw out that invisible implied hydrogen right there and say that's number 4, like that, right? So that's good. Number 4. I think right, that's good. And then now which carbon here would be number 2?
Carbon
Um
number 4.
yep, carbon number 4. Yes, yes, yes. Two, three, and going this way is also clockwise. But what would you notice that would not make this R because it's going clockwise, like on this current center
Uh,
here?
the hydrogen, it's
Hmm.
the hydrogen is supposed to be wedge.
Yes, right. So it looks R, but it's not R. It's gonna be S because
Yes.
the hydrogen is a wedge. Nice. Okay. Let's try this last current center here. Let's draw out this hydrogen for you as well, like that.
Yes. The bromine is 1.
Mm-hmm.
The hydrogen is 4.
Yes, yes.
Carbon number 3 is 2.
Mm-hmm.
And the last one is number 3.
Yes, correct. Nice.
It's
Um,
counterclockwise,
mhm.
so it's an S.
Yes, correct. And do we have to invert it to an R or is it good to stay as an S?
No, it's good
Yes.
because the hydrogen is wedged already.
Yes, yes. Good. So that's RS configuration. Um, Now there is a tricky example where if the lowest priority group is not a wedge or a dash, you cannot always do this trick where if the lowest priority group is on a wedge, we invert it to what it looks like. Right? So for example, if we have something like this right here, where this is the chiral center, this sulfur here will have the highest atomic number, and then this oxygen, and then this carbon here will be number three, and then this carbon here will be number four. Now, the lowest priority group here, which is this methyl group, is not on a wedge, not on a dash. It's on a flat plane. So to fix this, we would have to do rotation here.
Yeah.
This single bond right here can do free rotation. And let's say when I rotate that, I'm going to redraw this group, rotating these three groups right here, keeping this ethyl group stationary, keeping it still, right? So if that ethyl group is still and this bond here is rotating, I'm going to circle these groups to show you visually how I'm going to rotate this. I want the lowest priority group here to be on the dash, the backside. So I'm going to move the methyl to where the thiol or SH group is. That's going to move the thiol or SH group to the alcohol. And then the alcohol is going to become a flat plane bond like that, giving us this new, it's not the new structure. It's the same exact structure, but it just looks different because we rotated this single bond right here. And then the lowest priority group now has the methyl group. The wedge is now the thiol group, the SH group. And then the flat planar bond is the alcohol group now from this rotation, right? Because imagine you have a model kit and you're holding this ethyl group by one hand, and then you're rotating this single bond right there. And when you rotate that, these three groups will orbit around each other like that. And the
Yes.
reason why we
Yeah.
do that is because that allows us to have the correct priority system where the lowest priority group here is on the backside. So now when we do it, it goes counterclockwise, which will be S, like that, right? So that's the time when you have to rotate a bond to could assign RS correctly. But if the lowest priority group is on a wedge, then you could just invert it to whatever it looks like. Okay. Any questions on that one?
Yes, clear. Thank you.
That's good. That's good, of course. Okay. So the next thing you wanted to go over is meso structure. Okay. So let's go over that. So a meso structure is going to be a molecule that has two chiral centers usually. So two chiral carbons. And one is going to be R and the other one is going to be S. And there will be a plane of symmetry, meaning that there is a plane or a line where the molecule is going to be identical or symmetrical on both sides of the plane. Okay, so an example of that would be something like this, where if you have a chair like this, and say you have BR going here and BR going here, and we were to redraw this, and let's say we use the same technique as we did earlier, doesn't matter how we number it. What matters is the consistency of where the groups are at on the numbers, where we see at both carbons 1 and 2, we have bromines going up. So they're both going to be wedged on carbons 1 and 2, like this. So in this molecule here, we do see two chiral centers. One is here, another one is here, and there is also a plane of symmetry down this plane of the molecule right here, because everything on this side of the molecule is the exact same as everything on this side of the molecule right here, right?
Yes.
Okay, nice, nice. Now let's test the R and S thing. Can you tell me what is the configuration of this chiral center? Is it R or is it S?
We have bromine is one,
Mm-hmm. Bromine
the
is one,
hydrogen is four.
correct.
Yeah, the hydrogen is four.
Hydrogen is four.
The carbon number two is two,
Mm-hmm. Correct.
and the other is four.
Nice.
It's R. It's an R.
Three, one, two, three. It's clockwise R. Yes, nice. Now, just based on what we said so far, I would predict this is S, but let's make sure by saying that this is 1, this is 2, this is 3, and then going this way, which is counterclockwise, is S, and it will stay S because the hydrogen here is on the backside. So it's good to go to stay as an S. Nice. Okay. Now the planar symmetry is not always clear to see, right? Because for example, if you have this kind of molecule here, where we do have two chiral centers, right? But the planar symmetry is not uh like easily seen the way that it's drawn here, because if you make a line through here, this looks a little bit different than this, like as we see it drawn, because this is a wedge alcohol going up towards you. This is a dash alcohol going away from you. But if we rotate this single bond right here and redraw the molecule where we have this structure, which is the same exact structure, it's just redrawn, we now clearly see the plane asymmetry down this plane with two chiral centers here, right? Now the reason why we inverted this dash into the wedge here is because we want to maintain the RS configuration to make this the same molecule, right? Because if we were to assign the stereochemistry for this chiral center here, that would be 1, this would be 2, this would be 3, and then the hydrogen here, 4 is on the wedge. So we would have to invert whatever it looks like, which is going to be counterclockwise. Oh wait, clockwise, right? So it will not be R, it will be S.
Yes.
And we have to make sure that it stays S here. 1, 2, 3. This is counterclockwise, and it stays S like that, right? If we like made this a dash, this would no longer be S, this would be R, and these would no longer be the same identical structures, right? There would be diastereomers from each other. Okay, nice. Um, okay, the next thing is going to be EZ stereochemistry, and this is used for alkenes, right? Before we talk about that though, I wanted to also mention something. Molecule is chiral when there's at least one chiral center. So it could be 1, 2, 3, 4, but at least one chiral center, and there's no plane of symmetry. So if a molecule has like multiple chiral centers, but there's a plane of symmetry, that molecule would not be chiral. It would be achiral. So an example of that would be mesomolecules, like we were just talked about. This whole molecule here is considered achiral, even though there are two chiral centers, right? Because there's a plane of symmetry right here. Because of that plane of symmetry, that makes this molecule achiral, even though there are two chiral centers. Same as for this molecule here. Even though there are two chiral centers, the whole entire molecule is considered achiral because of this plane of symmetry here. So meso structures are going to be achiral, like that. Okay, nice. Okay. Any questions on that one?
Clear. Thank you very
Uh-huh.
much.
Yep, of course, of course. Are you
It's
uh-huh.
it's a personal question. What's
Mm.
your major right now?
Oh, what's my sorry, what's my what right now? Sorry.
What's your major? What are you
Oh, my
studying?
major. Yeah, yeah,
Yeah.
yeah. So, I went to UC Davis. I graduated from there 2024 with a biochemistry and molecular biology major, right? I tutored organic chemistry like the beginning of 2022. So that's like around 4 years ago. But right now I am in chiropractic school. Chiropractic school. So I
Yeah,
work with
yeah, yeah.
the human musculoskeletal system, like the skeleton, like the bones, the muscles. I'm currently in like my almost last year of school. I'll be done next year, June 2027, right? But I
So
wanted to keep tutoring organic chemistry because like I wanted to keep the passion alive for organic chemistry, you know?
it's a good thing. It's
Yeah.
very uh, good career, even if you are trying to
Mm-hmm.
pursue something else.
Right. Yeah. Yeah. Maybe like a lot of my friends said I should pursue like maybe becoming an organic chemistry professor or like a researcher. Um, I thought about it, uh, but I decided to go to chiropractic. But I'll see. I'll see. How about you? What are you studying right now, Mohammed?
I'm first thing. Sorry for my bad English.
Mm-hmm.
It's actually my third language.
Mm-hmm. Oh, English,
Yeah,
your third language. What are your first two languages?
Arabic and French.
Mm. Wow. Wow. That's good. Like, how long have you been learning English for?
Uh, 4 years, maybe 4 years.
Okay.
Yes.
Yeah, yeah. It's good. It's good. That's good.
Uh, I'm right now doing pre-engineering, physics and chemistry.
Oh, wow. Engineering, physics, and chemistry. All three at one time, during one time.
No, no, no.
Oh, okay, okay.
It's a sector that we are be. It's not engineering. It's 2 years of pre-engineering.
Mm-hmm.
We call them here preparatory state.
Mm-hmm. How's that going for you so far?
It's good.
Uh-huh.
We study physics, algebra,
Mm-hmm.
some organic chemistry, quantum physics,
Mm-hmm.
something like that.
Okay, okay. That's good. That's good. Okay. Um, so let's see here. Um, let's do E or Z, stereochemistry here. Oh yeah, how did you find about me again? It was it Instagram through Instagram?
Yeah, yeah, Instagram.
Wow. That's good. Okay. Um, so if you have an alkene like this, let's start with simple. And you look at the double bond right here, and you make a line through that. And let's look at each carbon of the alkene one by one. We have this blue carbon and this pink carbon right here. This blue carbon has a methyl group and a hydrogen, and we do the same priority like we did with RS. We look at the first atom and see which one has the higher atomic number, which in this case is going to be carbon. So for the blue carbon, I'm going to circle the highest priority group, which is this methyl group right there. The pink carbon also has a methyl group and a hydrogen, which the methyl group has the higher priority group. So I'm going to circle that higher priority group right there. Once you circle the highest priority groups for both carbons, right? One here and one here. Look at the relationship between those two highest priority groups in relation to this reference line over here. We see that they're on the opposite side of each other. So that means that they're going to be an E alkene, right? Because they're also di substituted, meaning that there's only exactly two substituents attached to it. We could also call this a transalkene. Transalkene, right?
Yeah,
You can't say cis or trans if there's like more than two substituents. Like if there's three substituents or four, then you have to do E or Z, right? The same thing for here. The highest priority group for that blue carbon is this methyl compared to this invisible hydrogen. The highest priority group for this pink carbon is this methyl group as well. They're on the same side now, so we're going to consider that a Z alkene or a cis alkene because it is exactly on the same side of this line right there, like that, right? Nice. Is my audio or cutting off, or is it good? Is it like smooth right now?
it's smooth.
Okay, okay, it's good. Yeah. So 'cause sometimes it cuts off so once in a while. Okay. Now I'll give you some examples here. Just give you two, and I'll have you try them out. Okay. Okay. Let's look at this first one here, Mohammed. What is your thought process on how you would solve this alkene? Would it be E or Z?
I will compare the both bottom ones. We found that the 135 cyclohexane, it's the number one of the priority.
Mm-hmm. So compare both sides. Um, let's look at this. Let's say there's two carbons of alkene here, this blue one and this pink one here. For this blue carbon here, what has the higher priority group? Um, this group or this group here?
SH.
SH. Yeah, so this is a tricky one. SH does have a higher atomic number than OH, but for the priority, we have to look at the very first atom attached to this carbon, which is this oxygen compared to this carbon right here.
Ah, yes,
Right.
yes, yes.
Yeah, the SH is not directly attached to the alkene, so the OH here would be the higher priority group right here, right? So be careful of that when you are looking for the highest atomic number. Don't look at like what's attached to this entire molecule. Look at the very first atom attached to that carbon right there, because that's the one that we're comparing to, right? And there could be some tricky questions on the exam that has these types of problems where they put like what looks like the higher priority group, but they're not directly attached to that carbon right there, right? Now, I think you said this one here is a higher priority than this group right here.
Yeah.
Yep, that's good. That is the higher priority group. So we notice that they're on the same side, which would make them E or Z.
Z.
Yep, correct. Z. Nice. Okay, let's try out this one here now. Say this is the blue carbon. This is the pink carbon. Tell me what is the higher priority group for the blue carbon and the pink carbon?
For the pink carbon, it's the
Uh-huh.
bromine number
Yep.
one,
Mm-hmm.
and the oxygen number two.
Mm-hmm. Yes. Oxygen is number two, but we won't take a look at that oxygen because we're
Great.
only worried about the highest priority groups on the pink carbon and the blue carbon, and then look at the relationship between those two highest priority groups, right? So
And
you're
for the other one
Mhm.
is it's the sulfur.
Yes, correct. And now once we have the two highest priority groups on like one for each carbon, look at the relationship for each. They're on the opposite sides of the line, making that E. Nice. Yeah, you got it. Okay. Mhm. Now, I know you said you also want us to go over priority of nomenclature, right? So nomenclature is my weakest area because I don't look at that much. I look a lot more about like reactions, mechanism, synthesis. But we can still go through nomenclature stuff. But there is a lot of things that go into nomenclature because there's a lot of functional groups. There's haloalkanes, there's alcohols, there's alkenes, alkynes, carboxylic acids, and their derivatives like esters, amides, things like that. And there's also the cyclic versions of them. What nomenclature problems have you seen so far? What functional groups have you seen? Alcohol, alkene, alkyne, or how alkyl halide, like regular haloalkanes. Do you have any like practice problems posted on your class or anything that we could work through for nomenclature?
I can
Hmm.
I can tell you what function I did
Hmm.
get from my teacher. You know.
Yeah, you could email that to me. I think you have my email, right? And then I could
Yeah.
import that through here, and then we could work through those problems together. Yep.
Okay.
Hmm.
Clear.
Yeah.
You want me to email it now, right now?
Uh, yes, yes. Yeah, yeah, yeah.
The only problem that it's in French.
Oh yeah, in French.
Do you want me to tell you what function there are?
Yeah,
And
you
you
could tell me that too. Yeah.
we have radical linked to to n and other radicals,
Radicals.
amide.
Oh, right. Let's see. Uh, can you type the functional group on the chat here, on the Zoom chat here?
Yeah, okay.
Okay.
It's okay.
Mm-hmm. Yeah. Mhm.
This, for example,
Oh, right, right.
and we
Amine.
can replace the two H par
Right.
other radicals.
Mhm. Right. So this is an amine right here,
Yeah.
right? And there are different types of amines. Um, there's NH3, which is ammonia. There's RNH2, like the one that you sent, which is a primary amine, meaning that it's attached to one other carbon group or hydrocarbon group. There's RNH and R2NH, where the two R groups could be different or the same, making that a secondary amine. Or there could be three R groups attached to the nitrogen, making this a tertiary amine, right? Because we know nitrogen will be neutral with three bonds and one lone pair of electrons like that, right? So, let's say for example, we have something like this right here. The highest priority group for this molecule is going to be this amine structure here, functional group here. And because this is the highest priority functional group over here, our number one carbon has to be this carbon, and then our number two carbon will be this carbon right here, because our highest priority group is this amine here, right? And because we see that our main chain is two carbons long, our prefix will be eth, right? Because like meth would be one, eth would be two, prop would be three, bute would be four, pent would be five, hex would be six, hept, HEPT, hept would be seven, oct, like octagon, would be eight, known would be nine, and then dec would be 10. Now, some classes also go through 11 and 12, but I forgot what that is, right? I memorized the 1 to 10 one, but some classes do test 11 and 12. So I would check your class or your professor's notes to see if your class requires you to know that as well, right? But know these for sure, 1 to 10,
Yeah.
right? Um, 2 is F, so F, and if it's a regular hydrocarbon chain like CH3, CH3, that would just be a ethane because we just have an alkane, right? But we have an amine here, so this would be ethamine, ethanamine, ethanamine, right? Ethanamine, right? Because we have the amine functional group here as the highest priority group. But let me double check this because nomenclature, my nomenclature is not very strong. Yeah, ethanamine. Yeah, ethanamine, aka because nomenclature, there's multiple correct answers. You could also call this ethylamine. Same thing, same thing. Right, nice. Okay. Now it can get more complicated if we get a secondary amine. Like for example, if we have something like this, and we have more groups attached to it. Like let's say for example, something like this. Okay. Now, what is the highest priority group here? What functional group do you see that is the highest priority group here?
The left one.
Um, the left one,
Ah,
this
the yeah,
right.
yeah, I understand
Uh-huh.
what you mean. It's the N one, the
Yeah,
N.
the N one, right? The amine one. So we have two functional groups here. We have halogen and we have amine, right? So the amine here, like you said, is the higher priority group, and because of that, um, this carbon here would have to be our carbon number one, right?
Number one.
Right. So if I were to tell you my like thought process step by step is like the first step for nomenclature is to find the priority group, functional group, like amine, halogen, alcohol, alkene, alkyne, right? So in this case right here, the priority group is this amine. From there, you find the longest chain, carbon-carbon chain, and then number it as is based on the highest priority group. And then you would identify the substituents. So like the other groups that are not the priority group, right? Substituents. And then you would then put it together in alphabetical order. In ABC order. Okay. So we know this carbon here is number one. This is going to be number two, number three, number four, and number five. So our longest chain here is this yellow highlighted chain where this is the highest priority group, the amine, and our substituents are going to be this bromine and this methyl here. So at carbon 3, we have a bromine, which in substituents form is going to be bromo. So we have 3 bromo. And at carbon 4, we have a methyl, so that would be a methyl, right? When you see a YL right here, that means that this is a substituent, right? This methyl group is a substituent. And we also see this substituent on the nitrogen itself. So we will say that that is N. And because it's 2 carbons long, 1, 2, it would be S. And because it is a substituent, it would be ol, right? N ethyl, like that. Okay. 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 Now, I don't remember if the N will always be first or do we put it together because I know that the longest shape because it's 5 carbons long, it will be pent, and because our highest priority group is the amine, we will have pentanamine at the end, right? And if we were to put in alphabetical order, um, like comparing B, M, and E, B comes first, so that would be 3 bromo, and then A, B, C, D, E, N, ethyl. And we put dashes, like you see the dashes here between like um numbers and letters, but I'm getting confused here about the N because like I don't remember if the N will always be first, but I'll look it up and make sure at the after this. Um and then we have 4 dash methyl
I think
pentanamine.
then at the beginning of the
Uh-huh.
nomenclature, at the
Yeah,
beginning of the
at the
name.
beginning of the nomenclature, yeah, the N will always come first right here. Yeah, right. I think that's right. Like this. Nice, nice. N ethyl. Yeah, that looks right. That looks right. Nice. Okay, and then 3 bromo, and then 4 methyl. Right, now that would make sense because the dashes will always be between numbers and letters. Right, a dasher between L and 3, dasher between 3 and B, dasher between O and 4, dasher between 4 and M. So between the number and a letter. And then pentanamide. Oh, pentanamine, not amide. Pentanamine. Like that. Okay. Does that make sense so far? Muhammad?
Yeah,
Okay, that's
clear.
good. Okay. Okay. Now, do you want me to give you practice problems based on what we talked about today? Like from the beginning to now? For you to
Yeah,
try
it's okay.
out?
Yes.
Hmm.
Thank you.
Okay, let's do it. Okay, let me see what we talked about. We talked about chiral sensors, RS. We talked about mesostructures when molecule is a chiral or achiral. We talked about EZ. And we talked about amine nomenclature. Okay, let's go. Okay. And then I'll also send you the notes of this session as well after and the private recording for you so you can review and for the notes of the session later on your own time as well. Okay?
I really appreciate that. Thank
Hmm.
you.
Yep, of course. Okay. Um, Now, number one, let's have you do this here. Okay. Okay. Let's start off with this one here. I'm going to ask you multiple questions in this one question, in this one molecule here. The first one is going to be, how many chiral centers do you see in this molecule?
There are two care center. Yes,
Yes,
I think.
one here and another one here. Correct. Now, what is the R and S configuration for each chiral center? Let's start with the red one.
Let me
Mhm.
write it on the
Yep.
paper.
Yep. Yep. Take your time.
The right one is an R.
Mm. The red one?
The blue one.
Oh, the blue one.
Or
Okay, the blue one. Yep, the blue one. So there is an invisible hydrogen here. What did you say was the RS configuration for the blue one?
R. It's an R.
R. Okay. Let's see. So, oh no, let's do blue. One, two, no, two, three. Going this way. Oh, okay. Clockwise. R, and the lowest parity group hydrogen is a dash, so that's good. It is R. Nice. Okay. Let's try the red one.
We can directly do the red one because there is plane of symmetry. Yes.
There is a plane of symmetry in this molecule, which is down this plane. And because of that plane of symmetry right there, and we have two chiral centers, what kind of molecule is this here specifically? Like there is a specific name for this molecule. When this molecule has two chiral centers and a plane symmetry. Nice catch. Right, two chiral centers, and we have a plane of symmetry. It starts with an M. Mm,
Meso.
yeah, meso.
Meso.
So this
Yeah.
molecule is meso, right? Because it has two chiral centers and a plane symmetry, this is considered a meso molecule. And because it is a meso molecule, is this chiral or achiral?
achiral.
Yep. This overall molecule is achiral, even though it has two chiral centers, right? Because it has this plane of symmetry, it is achiral meso. Now, there is still a RS configuration for red here, which is going to be counterclockwise S. So it will be S for the red chiral center. We can still assign RS for these two chiral centers because there are still chiral centers, but the overall molecule is achiral, right? Because of this plane of symmetry here.
Excuse me.
Hmm.
If the highest priority group in chair configuration was placed on the plane, you know,
Mm. Mm-mm-hmm.
not wedged or
If the lowest priority group is placed on the plane, not a wedge or a dash.
the highest or the lowest, the highest, for example.
The highest, yep, yep. So if you have a chair configuration like this, we know that in its flat structure that we are used to seeing in bond line structure is this right here. And if you look at every single atom of this ring right here, it is on a flat planar bond. And that means that the two groups that they're attached to has to be one wedge and one dash, right? Because if you look at this carbon here specifically, that carbon already has two flat bonds, one here and one here, right?
Yeah,
Because each carbon can only have two flat bonds and one wedge, one dash. Like a carbon can have two flat bonds, one wedge, and one dash, right?
tetrahedric.
Tetrahedral, correct. Hmm. And we see that every single carbon here of the ring already has its two flat bonds, flat, 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 flat. That means that each carbon here will have one wedge, one dash that we do not see. So if the highest priority group or lowest priority group is a flat bond, that means that one of these carbons here would have to be the um highest or lowest priority group. So for example, let's try to say let's say this is a hydrogen. Oh no, yeah. If we're trying to make this carbon here the highest priority group, let's say this is hydrogen. Um, let's say this is a bromine. And then if we want this to be the highest group, then this has to be, let's say, deuterium ion, which is an isotope of hydrogen. And if we look at this chiral center here, this would be number one, this would be number two, this would be number three, this would be number four. Now, when we do that, the lowest priority group is still on the dash, so we can still do it regularly. One, two, three, four, R. Right? But now let's try to make this carbon here the lowest priority group instead. Right? The lowest priority group instead. So when we try to make that the lowest priority group, let's say we have bromine, alcohol, and chlorine. That would make this number one. This would be number two. This would be number three. Now, be careful here, right? Because chlorine does have a higher atomic number than oxygen. This is not number two. This is number two because this oxygen here is directly attached to this carbon here that we are interested in, right?
Yeah,
We're comparing this oxygen with this carbon here that is directly attached to that carbon, not this chlorine right there, right? So be careful of that as well. And this would be number four right here, right? And you know how we said earlier to fix that problem, if the lowest particle is on the four, is to rotate the bonds, right? We can't rotate this bond here, even though it's a single bond, because it's part of a ring, right? And because of that, let's see here. Let's see what we can do. I have never seen a problem like this, but um, this would be a problem because we can't rotate this bond. Let's see here. One, two, three. This goes counterclockwise, S, but the lowest priority group here is here, not here. Bromine, alcohol. That's a good question. That's a good question. That is a very good question because you can't rotate this bond to make this into a dash. Mm, I have to look into that. I'm not too sure. I'm gonna start this and look into this here. Nice. Okay. But on all the exams I've seen for the different organic chemistry classes, I have not came across this problem yet. But that is a very good question to ask right there. Like, what if
It
the
came
lowest?
across me once something like this, something like this.
Hmm.
He translated to the 3D model, like the
Oh,
chair one.
right. He translated to the 3D model like this right here. Okay.
Yeah. Then
So, see, let's say this is one. Let's say this is two, three, four, five, six. And let's say this is one, two, three, four, five, six. At one, the bromine is going up because it's a wedge. Alcohol is going down because it's a dash. At two, chlorine is going down because it's a dash, like this. And then this is going to be the pink chiral center that we're interested in, where bromine was number one, alcohol was number two, this carbon was number three, and then this carbon here was number four. Okay, now once we have the chair confirmation, what did your professor do?
he wait 1 second.
Uh-huh. Yep.
He considered uh, the right between one and two, carbon one and two.
Carbon one and two. For
He
the
considered it
uh-huh
going outside.
outside. Okay.
Yeah. And the alcohol, consider it going for you, inside.
Mm-hmm. So that's outside, and then alcohol is going inside. Inside. Okay. Outside meaning dash, inside meaning wedge.
Dash.
Okay,
Yes.
okay. Good. Outside dash, inside wedge.
No. The opposite.
Oh,
Sorry.
opposite. Okay. Outside wedge, inside dash.
Dashed.
Okay. Okay. So, mm, okay. And then he considered these the flat bonds right here.
Yeah,
Flat bonds.
exactly.
Okay. Hmm. Hmm. Because we want the lowest particle group 4 here to be on the inside, the dash. But how would we rotate this to flip that here? It's
He
interesting.
considered it like it's a simple molecule, without
Mm,
the hexagonal shape.
mm. Simple molecule.
He
So
uh, he did the work with one carbon at a time.
one carbon at a time. Okay. Okay. So which so how did he assign priority for here? Let me erase the numbers. Erase all these numbers here. And he said this is the inside, this is the outside. How did he assign priority for this car center here?
You want me to give you the exact problem that he gave?
Yes, that would be great. That would be great.
I will send it to you by email.
Hmm. Okay. What time is it for you right now?
It's 9 o'clock.
9 o'clock
PM.
p.m.
PM.
Okay, okay. Yeah. Right now for me it's 12:55 p.m.
Oh, it's very late for you.
Oh no, 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 not a.m., not midnight. It's like
PM. Yeah,
p.m.
yeah,
p.m.
noon.
p.m. noon. Yeah, noon time. Yeah, the sun is still out. The sun is still out.
I think you did get my photo, yes?
Let me see. Email. Uh, email. Let's see here. Uh, let me see. Let me see.
Can I simply send it to you by Instagram?
Oh, Instagram. Okay, 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 okay. Yeah, yeah. You
Better, it's
can.
better.
Yeah. Yeah. Let me look at my Instagram. Okay. Instagram. Yeah. Yep. I see it. Okay. Screenshot. Oh. Huh. Um. Let's see. It says I can't screenshot or record this. Only meant to be replayed once. Is it a way where you could send the
Yeah,
photo
yeah,
directly?
yeah. I send it to
Yeah.
you second time
Okay.
so you
Okay.
can.
Oh, I got it. I got it. There you go. Okay. Crop. Airdrop. Okay. Uh, okay. Nice. 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 Got it. Okay. And go here. Just rotate around. Nice. Okay. Slot. Okay. Nice. Okay. I'm gonna share my screen again. Okay. Oh, did he do this diamond shape or triangle diamond shape
Yeah.
uh structure here as well with the Newman projections? Wow. Dang. And then he made this dash, a wedge. It's interesting. Okay. Yeah. This is my first time seeing this concept. I'm gonna have to review it. And then once I review it, I'll probably make a video for you and send it to you. Um explaining this more in depth for you, Mohammed. But thank you for sending me this. I'll look into
Thank
this
you
and
very much.
I'll make a video and send it to you. hmm That's good. Any other questions, Mohammed, before we end this session? I'll send you the notes and recording for this.
I appreciate it very much.
hmm
Thank you for the trouble.
Yeah, no worries, no worries. I'm glad. I'm glad to meet you. It's nice to meet you.
Thank you
hmm
very much.
Yeah,
Thank you.
yeah. Have a nice night.
Good night.
Mhm.